Hello, everybody. This is Tolga from Dijitalis. The topic of my presentation is workforce planning and scheduling with Simio. Before starting my case study, I would like to introduce my company. We are based in Istanbul, Turkey. We are established in 2006, and since that time, we have worked with 150 customers with 400 simulation and digital twin projects, not only in Turkey, but as well as 13 different countries. So what we do? We use the simulation and digital twin technologies so that our customers can maximize their value by building the right capabilities and to more efficiently utilize their assets and optimize their processes. So these techniques could be used in the whole supply chain, as well as the factory design, the warehouse design, and the internal and also the outbound logistics. That's why we call ourselves as the digital twin experts. In our projects, we were able to simulate the whole end-to-end supply chain, as well as the logistics movements inside a single facility, such as the interlogistics of a factory. And if we go also a deeper level, we built lots of simulation models for a manufacturing site or a production line or an assembly line. Also, in a deeper level, we built the simulation models of a single machine or a work center with some manual work of the operators. So as we mentioned, we have utilized the simulation and digital twin technologies to help our customers in many different geographical regions, from Europe to Asia, from the Middle East to the Africa. So let's have a look at our agenda for today. So we are going to talk about the business case for the workforce and planning and scheduling. And then I will define our approach. And finally, I will share with you the tangible results of the project. We worked in this case with a company who is the global player of tire and construction reinforcement and composites markets. Today, the company reinforces 1 of every 3 automobile tires and 2 out of every 3 aircraft tires worldwide. So in this project, we focused on the core twisting process. And in that process, there are 67 manufacturing lines. We tried to visualize the length of these manufacturing lines on the left side with a photograph, and on the right-hand side, a view from the simulation model. So each of these 67 manufacturing lines are more than 200 meters long. And each twisting line has 118 workstations that requires a manual operation from a human. As you can see from this chart, from a single twisting machine, as I mentioned, there are many stations. And as soon as a station finishes its production, it requires a worker to a manual operation to start the next production. So when you aggregate them to the twisting line itself on the bottom part of the screen, you see that if and only if the operator is on time, that the production can continue without any loss. So if the worker does not go to the station at the requested time, the machine will stop producing and a loss in the manufacturing capacity will occur. So the goal of this project is to determine the optimum number of workers to minimize the capacity loss. So for this company, we propose the client to build a digital twin of the whole twisting plant. So if we can represent the 100% of all the rules and constraints driving the operations, then we can come up with an accurate calculation of the staff requirement. And thanks to the simulation, it will be possible to break down the utilization of all the operators in the tiniest activity detail. For example, you can see an output of the simulation model, which shows a small section of the production facility where only 5 operators are involved. So in a manual calculation without using the simulation, of course, the utilization can be calculated, and then you would say that 5 operators are necessary to complete this task. But with the simulation, when you break down the activities, you will see that actually the 4th operator has a lot of idle capacity, which is visualized in this gray portion. And on top of that, the other operators, for example, the 3rd and the 5th one, has a lot of time lost in the travel time. So this gives us the idea that if we can somehow improve the layout and shorten the walking distances, so there is indeed a potential to get rid of this idle capacity by balancing the load of the 4th operator to the other remaining operators, which will result in a saving of 1 operator from this process. So we propose the customers that we are going to import the scheduling results, and that computer is using the SAP PPDS as a scheduling tool. And then we will import this production schedule and run the simulation model according to the schedule. And we would see actually how many operators the simulation model is using. On the left-hand side, you could see from day to day how many operators will be necessary so that the machines will not stop. And likewise, you can also see the utilization of all the operators in this pool. Also, we told our customers that we can also support the scenario building. So from the imported schedule, our customer can have some forecasts like the production increase scenario or the production decrease scenario, and then they can also decide what should be the optimum number of workers. And also by the experiment manager of Simio, it is also possible to try out different values on the size of the workforce and see what will be the effect on the capacity loss of the machines. Also, one other important requirement of our customer is the sustainability of the simulation model. So once we build the model, in the coming months, there may be some new machines added in the facility, or there might be some layout changes. So if the model is a data-driven model, it would be possible for the customer to enter a new machine to the layout and also the route table, and then the simulation model will update automatically. For this reason, we propose this approach, that in the first phase of the project, in the simulation model, we would model the layout plan, all the machines and the cycle times, all the setup times, and the breakdown and failure statistics of the machines. And then, together with the customer, we will define the operator groups, what are the responsibilities of each group, and what would be the rules to assign any operator to a specific activity. And then we would have a dynamic input integration with SAP PPDS for importing the schedule outputs. And after this simulation model runs, we will be able to show our customers for the next month or the next 6 months or the next 12 months. It really depends on the schedule that you feed into the system. There, they would see the required number of operators by activity groups. They would see the utilization of each generic operator. And of course, this will be a nice tool to validate the results of the scheduling software. Our next phase is the second phase, where we are going to integrate the simulation model with the SAP MII module. This is basically a manufacturing execution system developed by SAP. And in that, we could see the instant machine failures and downtime. And then the system would run again. And this time, additionally, we will be able to give our customer a daily operation plan for the specified operator profiles. So every morning, the operators would have an updated activity list, and they will see beforehand at which time they need to go at which station. And this would be update itself when a machine fails or breakdowns. So the modeling principle is that, of course, we are integrating the production plan from SAP PPDS. And we are also getting inside all the master data that's required to run the model. Then it will require some data transforming, which we did outside of Simio on a small module developed by Python language. And so that everything is happening automatically outside and the data is prepared for Simio to run. And then Simio runs to show us the resource utilizations, the product quantities, the workforce size, and the bottleneck analysis. One important thing in the simulation model is that whenever there is a worker who completed its assigned activity, it looks at all the waiting activities. So there might be different activities as listed here. So it could be a setup activity, or it could be any of the 6 main groups of activities. Here we had an additional module attached to the Simio model, which is prepared by a Python language. It runs a prioritization algorithm, and then it gets the result back to Simio, and then Simio runs a simulation and the operator goes to the next activity, which is determined by its priorities. Here you would see a screen capture of the process model of this task. And each time underneath this screen, there's a data table, and the priority of the next activities is determined by this Python algorithm. And then Simio sorts the activities according to the priorities and decides what the operator should do as the next activity. So what are the results of this project? First of all, I would like to show you a video of the simulation. Since it's a big factory and very long lines, so you would see that there are lots of walking distances for the operators. So that's why it's important to cleverly assign the operators to the next activity so that we minimize the walking distances. As you can see from this video, all the operator tasks from production to the material flow has been modeled. I will fast forward for you. So by looking at the size of the machines and the layout, you would instantly see that the walking distances are very important thing to consider. So here you can see that the simulation model accurately forecasts the production output of the factory, and in return these are compared with the PPDS results, because the SAP PPDS module is actually generating some optimistic results, because it only takes into account the capacity of the machines without regarding the operator availability. So it really makes sense to validate the PPDS results with a more accurate simulation model, so that they can get back the lessons learned from this simulation model and then improve their scheduling process. Likewise, we are able to calculate the utilization rate of the machines with a much more accurate calculation of all the loss types, such as the setup times, the worker times, the failures, and any kind of delays caused by the operators and all the other efficiencies. As mentioned, we are able to show the task-based utilization of all the operators, so that the planners at the company can look for improvement ideas. So here are some additional scenarios we tested on the simulation model. There was an idea that, as I mentioned, there are different operator groups assigned for certain activity groups. So there was one idea in the planner department that if the pooling of the operators would help the efficiency. So when we run the simulation, actually you will see that if they had a pooling of the operators rather than the dedicated teams, they have a 20% of inefficiency. So the pooling idea was overruled. The second scenario they wanted to try was, in the simulation model video, perhaps you've seen that some operators are responsible for carrying the materials from the machine to the supermarket area back and forth. So there was an idea to increase the cart capacity, which requires some investment because they need to change all the carts. But here it shows them that increasing the cart capacity would help the operator count by 13%. Also, we mentioned about the long distances in the facility. And there was an idea to move some of the machines to open a new aisle to shorten the distances. We also simulated that idea, and it shows that although there are many efforts to be made to create a new line, it shows that the results will not be sufficient to justify this layout change. So for only 1% of efficiency increase, there really was no reason to move the machines a little further to open this new aisle. And there was also another idea to increasing the speed limit of the transpallets by only 1 kilometer per hour. So according to this scenario, just by increasing the speed limit by 1 kilometer per hour, it is possible to have a 8% of saving on the workforce. So also, I mentioned during my presentation that since the Simio model that we built is much more accurate, because we were able to model all the rules and constraints of the production plant, so it created more accurate results. And by comparing these results to the results of the PPDS scheduling tool, so they were able to get back and change the algorithm of the PPDS module for a better line balancing. And in return, they achieved an 8% of efficiency with the line balancing. So all in all, in a composite scenario, the company decided to implement some of the proposed changes. And you could see that one by one, if all these improvements are implemented, a total of 26% of saving in the workforce could be achieved without any capacity loss in the production. So as a final word, if you need a digital twin expert on your site, I would like to draw your attention that we are kind of in the center of the world. So on the left-hand side, you could see all the business and leisure travels of all the flights in the world. So it really shows our location is geographically and time zone convenience, and we are at your disposal on your next project. I would like to thank you for your attention, and I will be more than happy to answer your questions.
Hey, Tolga, excellent work. And I'm always taking notes during your presentation because we'd love to have our example models look more like your models that you built. We have a really nice mix of some technical and some non-technical questions from the audience. So we'll start here. So can you tell us, how was the business attempting to manage labor planning before using Simio, and why is Simio a better tool for the job?
Yes, a good question. Well, they were using their, let's say, experience. And for some parts, it's based on the experience. And for some parts, it was left to the decision making of the shop floor chiefs, the operator chiefs, to take care of this kind of activity assignment. But after some time, their measurements show that there are really room for improvement for that kind of planning. So it was mostly manual work. And why did they choose Simio? Because the other tools that they use to plan and optimize their production are totally ignoring the operator capacity. And it was only by the simulation modeling that we were able to 100% representation of the shop floor and the requirement for the operators. So that's why actually our customers chose to do this on Simio and with our help.
Excellent. And we saw the impact of really modeling all that detail in the results that you shared. So that was great to see. Next question here. I think folks were pretty interested in your Python integration. So does the Python algorithm determine the activity prioritization evaluate during the simulation run or before the start of the run?
It has two phases. First one, it does before the simulation run, and for whenever the one of the operator is finished with the task, and if the open activity list has more than a few different activities, then of course there's a necessity to prioritize those orders. But if the same type of orders are in the open list, then there is then the operator is free to choose on its own. So it only depends on the number of open activities on the data table that triggers this prioritization algorithm.
Great. Great. Yeah, it's exciting to see Python being integrated with Simio. I know a lot of our users are interested in that. Next question on the data side. Did you import data directly from SAP, or did you use a database or another tool between SAP and Simio?
Of course, it is perfectly possible to get the data directly from the SAP, but probably all of us has experienced the reluctancy of the IT teams that they don't really let you to touch the SAP table. So it was the same in this case. So they exported the relevant data to a database, and we were integrated into this, let's say, a safe database, and we retrieve the data from that.
Sure, we certainly understand, the importance of security and IT protocols, so that makes sense. Last question here, sort of related. Can you tell us how the outputs or the task list outputs from Simio were ultimately distributed to the operators?
Mm-hmm. Of course, not all the operators are the same. So there is a skill matrix, and there is of course, from the whole operator pool, only there is a handful of operators that is skilled or trained to do that activity. And of course, some of them could be already busy with the assigned tasks. So we really use the activities, and the operators has different groups. And although there are so many operators in the shop floor, the potential candidates for an activity and operator assignment was not so high. So it was, in that case, easier to manage.
Terrific. All right. Well, I think that's about all the time that we have. Tolga, thank you so much. Nice to see you. And looking forward to next Simio Sync.
Me too. Bye-bye.
This concludes this presentation. Please click on the back button to access the next presentation.